Imagine you're doing legal research and you see a citation to H. Rept. 17-20. By looking at this citation, you can probably tell that this is a House report. If you have experience with legislative history material, you might also know that these numbers mean that this is the 17th Congress's 20th report. Considering that the current Congress is the 118th, and that the United States Congress has one session every 2 years, we can assume that this document is about 200 years old. So what research steps would you use to try to find it? The fast and easy one would be to use Google. This might give you the answer, or it might not. After all, with the age of the document we're looking for, online availability can be kind of spotty. Where else would you go? Westlaw? Congress.gov? Govinfo.gov? ProQuest? Your local federal depository? Maybe these places have coverage, or maybe they don't. But take a moment to observe the process that we're using here. We started with the total universe of things that we have access to, a practically infinite number of resources, and we started narrowing it down, looking for the specific document where we think it might be. For instance, good sources of information such as the New York Times website or Pacer probably wouldn't help us here, since they don't have the type of information that we're looking for. The shape of our approach kind of looks like a funnel. We start with everything, and we work down to find the something that we need. From the options we've identified, could we narrow it down even more? Westlaw probably isn't the best place to look since it doesn't have great coverage of legislative history material. Congress.gov would be great if this document were more recent, but this might be outside of Congress.gov's date range. Govinfo.gov is the winner here, finding us the document that we're looking for. But while you're looking for your House report, you see a news article about how AI is revolutionizing work, as well as advertisements for AI tools offered by legal database vendors. You think to yourself, how does AI do research? Would it do what I do? AI models begin with data. Tons and tons of data. GPT-3 used the training dataset of 45 terabytes. For scale, that's over 60,000 copies of the United States Code with no file compression. And the size of GPT-4's training dataset has not been disclosed but is speculated to be much larger. This data can include anything: news articles, social media posts, recipes, blog posts, anything that can be inputted into the model. You may have heard a lot of different terms thrown around, such as deep learning or large language model, but what do these actually mean? These are all a type of artificial intelligence technology called machine learning. Machine learning modules use data to tune a number of mathematical parameters that find patterns in the data, such as patterns in language. For example, a common pattern in English is to follow "Hi, how are?" with "you." If we were building a model which could generate English language content, we would want it to be able to fill this in. Because of the lack of clarity about training material, it is impossible to say whether or not a given piece of data, such as maybe House Report 1720, was part of the training data set for the model. If it were, the only difference it would make would be in minuscule adjustments made to the stored parameters inside the model. Each piece of data makes small adjustments like this, allowing the model to identify trends. This could be things like sentence structure, idiomatic phrases, and topics and words that are often used together. That entire volume of data is distilled into a single model, which itself isn't very big. For example, although it trained on over 45 terabytes of data and contains 450 million parameters, the medium version of GPT-3 can fit in a binary file that's a little larger than 3 gigabytes. That's not even 5 copies of the United States Code. If the machine learning model doesn't actually retrieve the document we're looking for, then why might it seem like it not only knows about the document, but has actually read it? Once the model is trained, it can be used to generate a response to a prompt. We mentioned an example of this earlier, filling in "hello, how are" with "you." But if you wanted to keep it generating text, you could feed the prompt into the model again and again, appending the last bit it generated to the input until you get the length you want. So the shape of the language model's process is sort of the inverse of our funnel. From one relatively small model, you can get functionally an infinite amount of text. But what if you wanted the model to answer the question, "How are you?" It might say, "I'm happy" or "I'm sad." But what would this response mean? If its training data contained a significant amount of conversations between people, responding to this question with "I'm happy," then the model would probably learn that pattern and say, "I'm happy." If its training data contained a significant amount of conversations where people replied, "I'm sad," then the model would probably respond, "I'm sad." Note that the model is not doing what a person would do. A person might examine their internal emotional state and give a reply corresponding with their understanding of that state. Or at least they would pretend to. Instead, the model looks at its inputs and runs it through its trained parameters, generating an output according to the result of its mathematical calculations. If it responds that it's happy, it's still just a bit of code sitting on a machine. It's no more happy than if some of its numbers were different and it responded that it was sad. So what happens when you ask it to do research? That is, if you asked it a factual question that you didn't know the answer to, well, it would do the same thing. It does not run a search and return a response based on what it finds. It doesn't use the same kind of research steps you do. Note that some AI models do this now, but it's a different functionality which is not a part of how machine learning fundamentally works. Is this a good way of doing research? Well, it's hard to tell. For some things, it can be quite good. If you ask it what date Christmas is on, it will probably get it right. We can assume that there's a strong association between Christmas and December 25th in its training data because there's a strong association between the two generally on the internet. But what if we ask it questions which aren't as strongly correlated in potential training data, such as asking it about House Report 1720? Well, when I asked ChatGPT 3.5, it failed spectacularly. It clearly confused 17 with 117, since the 117th Congress was in session during 2021 and 2022. However, I looked up the actual House Report 117-20, and it's a separate bill named the National Origin-Based Anti-Discrimination for Non-Immigrants Act. But then what about the Veterans Compensation Cost of Living Adjustment Act of 2021 that it cites here? Well, in the House, that was 117 HR 3909, and in the Senate, it was 117 S 189. Maybe the model connected 20 with 2021? No one knows. Literally. Here's the thing about commercially available large language models. Nobody knows. Even the machine learning engineers don't know the effects of individual parameters. Even if we had a model downloaded and could look at the numbers stored inside, it would still be an incomprehensible pile of numbers. If you want to see this for yourself, there's an excellent project called Spreadsheets Are All You Need, where you can download the model for GPT-2 in Microsoft Excel and run it. So if a human legal research process looks like this, and a large language model's research process looks like this, is there any point in using the large language model for anything? The best answer is probably the legal industry's favorite response. It depends. As we mentioned earlier, there are some questions that these machine learning models can reliably answer. For instance, if you asked it about better-known topics like the 13th Amendment or Brown v. Board of Education, it would probably be quite knowledgeable. There are also a number of tasks in studying and practicing law which do not play to the weaknesses of large language models the way that this sort of technical research does. Large language models might help with initial drafting, idea generation, tone revision, and other use cases. But for legal research, as with all instances of AI use, make sure you verify the model's response, and remember that it does not do research the way that you do.